All right, so the next speaker, we actually have some Toronto in town. We have next two speakers from Toronto. I know Olga from the meetups in Toronto, and she's working at Pivotal as a product manager of Spinnaker. So I said, why you should come to Montreal and tell how's things going with Spinnaker, what's new there, how you can use Spinnaker with Kubernetes. And she kindly agreed to come and have a nice talk with us. So please welcome Olga Kundzich from Pivotal.
Yeah. Okay, I'll do a review of what Spinnaker is, and then I will talk about primarily what Spinnaker brings to Kubernetes. So Spinnaker originated at Netflix. It's their own continuous delivery solution. And it has been open sourced a while back, and it has a lot of contributions from different cloud providers, including Kubernetes, and has a really large community. It's a tool that has been battle tested. From small startups to large technology companies to large enterprise companies. So originated in 2012 when Netflix was going to the cloud with microservices, and they realized it's not appropriate to use a AWS console for developers. They built a dashboard called Asgard, and then it didn't scale, and eventually they just decided to introduce a completely brand new tool, Spinnaker. Google partnered with Netflix and helped them open source this tool. Then they partnered with Netflix again and took the years of knowledge of how to do canaries and build up an automated canary analysis stage. Then Pivotal last year started to contribute to Spinnaker open source. And this year, this has been donated to Continuous Delivery Foundation to formalize how this community works. And the emphasis when Netflix built Spinnaker is build guardrails, not gates. So three main things that Spinnaker gives you. First of all, it's the inventory of application integrated with monitoring. Remember, it's originated as a dashboard, so it pulls from all of the environments and creates you different views for your inventory and for your pipelines as well. So it's very efficient in how it utilizes resources and scales. Of course, it has pipelines with different security and safety practices built in. And finally, it has a lot of guardrails built into it, starting from manual judgment to traffic guards to conditional executions, notifications, zero downtime deployment strategies, chaos monkey integrations, rollbacks, and finally, automated canary analysis. And we just saw another canary analysis, so it's nice to compare. So again, two key insights from years of working with this at Netflix. It's not valid to evaluate canary against long-running production application because production application has been running for a while. They populated caches. They built queues. Newly deployed canary does not have anything, and the results are going to be skewed. And the second part is it's not valid to validate canary against the fixed thresholds, right? Well, that we saw in the previous demo, it was validating against like 30 milliseconds latency or something like that. Production traffic varies. So if you validate it against fixed thresholds, you will not take that into account. But there you have like peak traffic conditions or off hours conditions. And this canary analysis can actually run multiple times across different periods of time, like morning, afternoon, and evening, and validate all of this together. And it's sort of differentiated analysis. And like you see, it's very hard to set up. Baseline canary attached to load balancer and can configure metrics that you want, and you don't want just two metrics, you want probably a set of tens of metrics that you want to evaluate it against. So Spinnaker lets you set it up fairly easily. So this is the spinnaker ecosystem. It's a complex tool, but it gives you a lot as well. And like we saw, that spinnaker originated before Kubernetes. And it was VM-based. And it's kind of, when you speak about spinnaker, people will usually say, oh, it's old, it's VM-based, and it's not applicable to Kubernetes. And recently, we finally worked it out how spinnaker is a complementary tool to Kubernetes, what it provides. So spinnaker itself needs to be deployed onto Kubernetes. It's number one. You can deploy it somehow else, but this is kind of the community practice, and we're trying to standardize to make sure that everyone has like a single deployment paved path for deploying spinnaker. Can manage applications on all other cloud providers, VM-based deployments, cloud like Azure, GCP, AWS, multiple Kubernetes clusters, Cloud Foundry installations. So it's where it sits, it orchestrates business process of software release across Kubernetes clusters with deploying Kubernetes manifests into environments using kubectl apply-f, so it can deploy any manifest. Pretty much imperative pipeline across environments. This is spinnaker. Business logic varies enough, and it's hard to encapsulate, and it doesn't translate across the different organizational boundaries. So that's spinnaker, but for a person, it's really easy to say, do this, then that, and then, do canary, and then push it in production if canary is succeeding. And then declarative spec for each environment. Well, it took us some time to figure all of this out. And again, the credit to all of these ideas goes to Andrew Phillips, the Google PM we are working with. Using spinnaker in the early days was tough. That's kind of understatement. I would not recommend anyone 2 years ago to try to do it. Netflix runs spinnaker off master and deploys spinnaker with spinnaker, and they validate and canary each commit and roll it back or whatever. For people who do not have spinnaker in their environment, getting spinnaker was very tough. It's this many microservices. Figuring out which versions work together with each other was difficult. Figuring out how to configure them was difficult. Sure. So what did we do? Is it on?
Yeah.
Okay. So Google contributed and created two things. First of all, the deployment for spinnaker. Again, it was before Kubernetes times, or just when Kubernetes was shaping up. CLI for managing spinnaker, and the Halyard, which is a subset of spinnaker, deploying spinnaker. And now we are standardizing on Helm chart-based deployments of spinnaker, and things are going to improve as we make some improvements to how we manage accounts. And release process. We have a standardized release that packages those microservices, runs integration test, validates them, and publishes a fully qualified revision. And community is actually, it's fairly straightforward right now to deploy. And people in the community are keeping up with updates because everyone wants the latest features. And we also had Kubernetes V1 provider, which sort of took this spinnaker model, VM-based model, and implemented it for Kubernetes. And the Kubernetes community didn't like that, because Kubernetes is a platform for building platforms, and everyone wants their own. No one wants exactly the same platform as everybody else. Because at the same time, we all agree that Kubernetes manifest is not the right level of abstraction for application developers to consume. Also, Kubernetes manifest leaks all of the infrastructure details up, all the way, so Kubernetes clusters are not the same. So how do you do it across different organizations? So here comes another key insight. Kubernetes manifests as templates. Someone within your organization who manages Kubernetes clusters, who knows how they are configured, can provide templates for deploying applications of different kinds into these Kubernetes clusters. And from then on, application opinion and maybe operations opinions could be merged into these templates. And there's some different, an application opinion may be like, I need this much memory and this many instances. An operations opinion may be, these are the secrets to connect to production database. Application developers tend to not know them. And then there are different ways how you can organize this to help yourself manage this manifest hell that all large organizations are finding themselves in right now. You have DevTest prod, couple YAMLs for different infrastructure primitives for one application, multiply 1,000, and yeah. Anyway, you could eventually assemble that and store that as a separate record of what you have what you want to apply or what you applied into your environments and promote it across different environments. So also, like I said, this is out of this insight of Kubernetes manifest as template, the Kubernetes V2 provider was born, fully declarative, and will help you manage the manifest, merge them in through variable substitution. And also, if you want to leverage some of the spinnaker primitives like blue-green, canary, rollbacks for application and make it easier, you can instruct spinnaker to do it on top of your manifest, and it will use labels to label the infrastructure properly and route traffic and do all of these things. Helm and customize support. So Helm is implemented as a stage, and it will do Helm template, so your Kubernetes clusters do not need to have tiller in them. And customize support, so it will do Helm template, generate the manifest, allow you to further substitute variables in that manifest, and then leverage the native deploy manifest stage to deploy manifests into the environments. Customize support is coming similarly. It's going to be a bake, customize manifest, and once it translates to a native Kubernetes manifest, it will go into the cluster. Another idea was around artifacts and triggers. So in Kubernetes, your deployment consists of multiple artifacts. It could be multiple manifests, and could be multiple Docker images. And you give it to Kubernetes, and it assembles itself, resolves what needs to be resolved in the infrastructure. So each manifest now has to trigger the redeployment. So you have multiple, and you could see at the start of the pipeline, we have multiple manifests and the Docker image coming in, and every one of them will trigger the deployment. And every deployment stage will show you which manifests were consumed and which Kubernetes artifacts are going to produce. So as a stateful system, Spinnaker can actually help you audit trace all of this and output what actually has been deployed successfully into the cluster. Manifest processing, so this is an example of how you could parameterize things in the manifest. You could also compile manifest in the CI and gather all of that there in your own way. GitOps, things to consider. If we strip this down to a practice of having a record of what you have deployed into Git, then whether you trigger it with Spinnaker and deploy with kubectl, or if you pulled it from the inside with cluster with some CRD, you will kind of have different pros and cons. You either have to maintain a separate tool like Spinnaker, or you have to maintain this CRD, and then some considerations like your RBAC is now delegated to Git practically. Otherwise, you have to manage it in a separate tool. Consider the manifest that you supply into your Kubernetes clusters a statement of intent. This is not what's guaranteed to be reconciled and running in the cluster. So you also need some way of tagging what has been successfully deployed versus wasn't successfully deployed. Spinnaker can actually, after deploying things, output what has been deployed, and maybe you store it as your source of record of what has actually been deployed rather than requested. Kubernetes mutates manifest based on its configuration. It does it while you deploy it. It does it after you deployed it. It's not a stable system. And finally, the delete problem. If you delete something in your manifest and apply that manifest into your Kubernetes cluster, it's still running there. The deletes need to be explicit. Spinnaker has a delete stage that lets you do that. If you do it with the GitOps method where you monitor things with CRD, make sure you also delete it. So community governance, like I said, we have technical oversight committee, special intergroup, Kubernetes security, UI declarative delivery. We are working on these all streams. This is Netflix, Google, pivotal main contributors, and the security interest groups sort of run similar how the Kubernetes ones are run. We sort of also kind of started with the Google initiative. And roadmap. So working on making all of these credentials that we need to now manage from all of different pieces, making it secure and making it dynamically refreshable so it will make it even more simpler to maintain Spinnaker. Declarative delivery, it's very templated pipelines. You spend in security. The product been around for a while, so there is some technical debt to address. For Kubernetes specifically, we are working on more simplification and performance improvement, make it the easiest to deploy onto Kubernetes. And then Istio Knative. Everyone is asking me, practically all the time I hear this question, and when I ask what it is, do you mean, what do you need from Istio and Knative, I never really get an answer. So if you want to share with me, please do. With respect, because specifically Spinnaker now can deploy any manifest, it can deploy Istio-based manifest, could deploy Knative-based manifest, all of this. And respect to Istio, like we said, it was authentication, telemetry, authentication, authorization, telemetry, and traffic shaping, the three main benefits. The first two are transparent to Spinnaker. You will get these benefits if your clusters are configured with Istio. And the third one, we will probably integrate Istio as a routing mechanism for our canary analysis, so that you don't have to rely on round-robining canaries, what we have right now, but you can specify the percentage of traffic to ship to canary. And Knative, again, we and Spinnaker already implemented an abstraction on top of Kubernetes once. We're going to watch you implement another one on Knative, and when it's ready, we're going to pretty much fairly simply plug it into our resource model because it's, again, Kubernetes native. Resources. There is a book that Netflix and Google published. It's available on spinnaker.io. There is a Spinnaker Summit coming out. It's right before KubeCon North America. It's on the weekend before that in San Diego. So if you're going there, consider extending and spending some time with Spinnaker community. Spinnaker and Google platform is probably the best way to give Spinnaker a try. It's a bundle that they packaged and integrates with everything in Google environment, and you can be up and running and giving it a try within minutes. Again, Andrew Phillips' presentations, and more details on canary analysis, and really nice demo with Rick and Morty that my coworker put together, and it's linked for you as well. And demo, I just took this Spinnaker and Google Cloud platform when I was evaluating at the time, and I don't know. That I was evaluating at the time, I took the same pipelines, I just put them in my Spinnaker, I deployed them 2 clusters instead of 1, and modified some triggers. So here's how it looks. It has a config with, like I said, DevTest, prod, and staging, almost replicating each other, but not quite. The Docker image, the cloud build, YAML, and the blue-green application that we can edit and start running. Light. Green. Oops. and that will trigger cloud build. Then we'll produce a container in here, and then we'll deploy things with Spinnaker across these two environments. And if we are lucky, it will come in. So Spinnaker, this is, like I said, dashboard on top of multiple environments. You log in here, and that's what it will show. I have about 4 or 5 Cloud Foundry environments, Azure clusters, and GKE clusters, and this is the app that we've been deploying. So it gives you an application-centric view. This is deployed across the dev cluster and prod cluster, and deployed with replica set, so you can do some additional blue-green deployment strategy as done by Spinnaker. Pipelines, and you can see it's now triggered of the new Docker image and started running. And we look to configure, like we deploy namespace, service manifest, and replica set, then validate staging is also, all of these stages is of a type deploy manifest configuration. I just named it like this so I can understand what's going on. And then check validation. Where is it here? So what it does, it will also bind this Docker image in the manifest here. You don't have to specify the tag and manage that for yourself. It will resolve the tag from the Docker image that it received when the pipeline started. And then deployed to staging can be, deployed to prod can be much more complex. We could have a manual judgment saying, it will so the trigger, first of all, is going to come from the successful deployment of the deploy to stage. An interesting feature here, it will bring you the Docker image from that pipeline. So you don't have to specify it again, because I've made a lot of mistakes pushing different Docker images into different environments. So this is guarantees that it's going to be the same. And then you could have different scenarios. If it's succeeded, you could wait for 2 hours before you scale down the previous version, so you have a fast rollback. Or if it failed, you could roll it back automatically. I don't know if you want to wait. Yes. No. Yeah. Okay. Anything?
No, any questions? All right, thank you, Olga. Very brief, very interesting. We're inviting next speaker, if we have next one. Oh, there you are. I thought you didn't arrive, so starting to scare. So Olga will be on the speaker table. If you want to ask any questions about Spinnaker or maybe future roadmap, she will be happy to answer your questions.